we start, if somebody would feel comfortable outlining the lab that we did, what we measured, and then initial outlook, and we'll feed on from there. Would somebody feel okay just sort of giving me a quick summary of the lab that we did?
Of the actual, just the process of the lab?
Yep.
Oh, I guess I should. So essentially we were just testing, at what frequency and, or, the harmonic number, a certain number of, waves will form, I guess. Or wait, no, that was wrong, actually. Sorry, oh my gosh, I'm forgetting all my words. Someone else.
You're testing what frequency. You're testing what frequency was needed to create the different number of harmonics.
Yeah,
And
that's what I got.
and then you were comparing that and the other one.
And the distance of the wavelength that
Yeah.
created.
And we used one short string and one long string.
And with that data, we looked at the relationship between wavelength and frequency, and then frequency and the number of harmonic.
And graphed it, which created two linear graphs and two power series.
Should we talk about the graphs? The relationship, everyone, just before we should start, just check, like everyone had the graphs were pretty much the same for the short and long string, right?
They should have been exactly the same, because we all have the same
exactly the
data.
same, yeah. Alright, and then everyone had the inverse relationship, inverse relationship for the wavelength versus frequency. Yeah, and then frequency versus harmonic was linear.
Did we ever test the harmonic versus wavelength, or were we just told that that was not something we were looking at?
I graphed that one by accident, and I got a power series for that. I think I might have deleted, oh no, it's right here. Yeah, they're kind of, it's like the same relationship as the wavelength versus frequency.
Okay. Oh yeah, because the wavelength, the frequency is based on the, whatever harmonic you're going for, so it's just another, okay.
Do we remember how long the long string was? I don't have that number.
Like if you have to put it with the long string, that'd be actually really helpful.
I remember it.
Well, it's whatever the wavelength is for the first harmonic, so 2.36 meters.
That makes sense.
That's a good way to think about it.
And the short string would be 1.83.
I thought it was, okay.
Yeah, the first thing we'll find.
Okay.
Yeah, 1.8.
Sorry, can you say the long one again?
The long one was 2.36 meters and the short one was 1.83. Or, no, the short one was 0.91 meters, the string was.
That's half of the.
That's
Yeah.
half.
Oh, right.
Oh.
Yeah, because we measured it half.
Yeah.
So that's
So
how
you
long it
multiply
was.
by two.
Yeah.
So it is.
Well, but no, the first harmonic is
Oh,
only half of a
you're right.
wavelength, so it's whatever the first one.
What?
So it's 1.83.
1.83 would be a full wavelength, but for the first harmonic, it's only half of a wavelength, doesn't go back up.
Because it looked like this, kind of. But if you think about it, a wavelength would be like that, right?
So
Is the other one wrong?
the love harmon's wrong.
So the long string you back up there too.
No, because the long string, that's just how long the first wavelength, and that's not is that a full wavelength?
Yeah, we did like the full, like.
So then it would be half of
But
it.
that's what we measured for the whole.
Yeah,
Yeah.
if we did half of it.
Well, they're just on.
Wait, but for the first harmonic, you measured the half wavelength and then you doubled it for the first harmonic? Or do you just measure the whole
Just
string?
We just
measure
measured
the
the
level
string
of the string.
Well, then that's only half a wavelength.
I think it's like not, it's like 2/3.
No, it's half a wavelength, because if there's one, you have to go back up to get the full wavelength.
Right, but it would just be after.
So then
I
it's even
agree.
better if I could.
I don't,
Can
I
I
don't,
get the board?
I don't
Does it
know if
matter
that is
that much?
right, actually. Let me,
Can we
I
draw
have a
it on the
wavelength.
board
Oh, yeah, you're right, so it would be from top.
Yeah, it can,
To go.
so that everyone's like.
Yeah, I think it would be good to really draw it on.
Okay.
Oh, yeah, it does.
I guess it doesn't really matter, but.
I mean, it does matter, because it matters if we're measuring a full length wavelength or half a full wavelength.
This is what our group
This
measured
is what
for
we
the
did.
long string,
Which is.
here to here.
So then you measure half a wavelength.
But a wavelength is
Wait, no, so we measured.
that, right?
Yes.
So we were meant,
Half a wavelength.
So for the ones after that, did you measure from top to?
We measured from, Mr.
we would,
Rawson watched us. It was, I think it was just the first one that we probably measured, incorrectly. Because, I forget what the terminology is, but where the string looks like it's standing still in the middle.
Yeah.
What's that called again?
no,
No.
The node. We measured from the end of the string to the node. Or we measured the, oh wait.
Like no.
no, but we measured,
We didn't have
didn't we
No,
do
no
something
is
like,
half a wavelength.
like
Yeah,
that?
I think we were measuring half a wavelength because we only measured one arc.
Yeah,
Alright, so
We
then,
didn't know.
and that would be a fall.
Well, if all of it is half,
Okay, so
then we
then.
just have to double it, right?
or it's just all of it.
We don't even have to double it.
It's the same
Just
thing.
say
Or
it
because
was
both
half
of
of
them
the-
are one half.
If everything's one half, then it's right.
Yeah.
This is,
So
this is the
we-
weirdest thing we can choose about.
Yeah.
We just already measured half a wavelength for the long string.
Yes.
Yeah,
Yeah.
okay, so we should
We can change that.
change it.
We have to vertical.
No, we don't have to.
If your other one is already in half
It's in
wavelength,
half,
I
so you
converted
can-
mine to full, so.
I converted it,
Yeah, I converted the other one to full, so we're both at the full.
Yeah.
What are we, so are we changing, are we just multiplying both of the, are we just multiplying both of the wavelengths by 2?
You can if you want. Did you, when you did the short string, did you convert it to a full wavelength before you made the graph, or did you just keep it at half a
With
wavelength?
the long string?
No, but you didn't make graphs for both of them.
Oh, I need the graph for the small string. Sorry, can you repeat what you said?
Did you only make the graph for the longer string or the shorter string?
I made a graph for both.
Okay, well then you convert the shorter string, like multiplying all of them to data by 2.
No.
Okay, as long as you
Oh, I
keep your
didn't even see it
data.
said half wavelength. I'm just gonna leave
and-
Yeah, if they're both
Yeah,
half
yeah.
wavelength, it's fine.
That's what I have.
it. So it's, does
Okay, I need
everybody have?
I
No,
need
I
to
have
change
changed
it.
The relationship is gonna look the same, right? I mean.
Yeah.
Yeah, I guess like, the equation is exactly.
I was gonna say, would it help to look at the equations for both of
Yes.
them and see if,
Yeah, because Eva, you had the.
So, even do you have a full wavelength for?
Yeah, for the short string. For the short string, I converted it to a wavelength before I graphed it, but I think as long as you keep it,
And what was your equation?
my equation for the short string,
Yeah.
for the wavelength one, was 22x and then to the negative 0.992. That was the,
Yeah, like that.
Yeah.
And I had 11x to the negative.
So we have to convert to full wavelength.
So we should do it.
Or no, that's just, as long as you have the
It's
same
just
X
half,
component.
but
Yeah, it's on.
it's the same relationship.
Okay.
Mr. Rawson has mine on the board, it's got to load. I did the long string and I was treating it like a full wavelength and the equation was 10.8x to the power of negative 0.988.
Weird, I had 10.6x.
I had 10.6 too, but I just converted it into a full wavelength and created a graph, and it was 21.2 to the negative .98, which is really close to even short string.
Oh, that's why the,
Yeah,
so,
that's
that would make sense why the first, what is that called,
Harmonic.
No, the first number in a equation before the x.
Yeah, so, good question. This is a good,
The coefficient, that would make sense why the coefficients were so different for the long and short string. So if you make them either both half a harmonic, or half a wavelength, or both a full wavelength, the coefficients should be closer to the same.
But also, because of the kind of relationship that it is, does the coefficient matter, or are we just looking at the exponent?
I don't think it matters.
Because the exponent stays the same. Yeah. Or like almost the same. Like in the first one, it's negative 0.98, and the other one it's negative 0.99.
Yeah.
So it's like the same relationship.
So we're gonna agree that, like, it doesn't, do you think that we should, if we have the graphs using the half wavelengths, that we should change it, or it doesn't really matter?
I think we're saying that as long as the exponent between the long, like two graphs is the same.
Okay.
So we figured that out.
so let's look around the room for a second. A number of orange cups came up. Let's see if we can't now acknowledge some of the confusion. If we can try and concretely bring everybody back. And then let's try and see if we can get back to green for those users, okay? I'm trying to, on the fly, do what I can in order to listen to what you were saying. I believe that we were saying that this wavelength that was actually measured was actually half a wavelength and not properly one wavelength. Is that correct? Okay. Then, has anybody fixed it and looked at the updated graph?
Yeah,
And what do you notice?
it's the same. Just higher.
Is our exponent the same on both of the graphs?
The exponent that I got when I did the full wavelength was, for the long string, was negative .98.
And the short string, or the long string with the half wavelength was 0.988, or negative 0.988. Yeah, okay.
So we're saying that doing half versus the full doesn't matter because the coefficient isn't a 1.
Yeah. This might be an obvious question, but what is the coefficient like representing? Like if it doesn't matter, why does it matter?
That's a great
Next
question.
question. Probably this.
You guys know I don't know if you guys have it on paper or on your computer, but the exponent equation work with all the different, shows all the relationships. That I think kind of shows what the exponent means and like, yeah. And what the exponent represents is the right word, but like if you go to the exponent between 0 and -1, it'll show you what y equals x to the -1, which I think is the relationship we're looking at, right? What that means for the curve of the line. So it's
So that creates the curve and then going off of math knowledge, the coefficient would make it, would like stretch it or compress it, right?
I think so. What's the equation? I think it's 1.6.
So the exponent is what creates the actual like, yeah, or
The relationship.
the relationship.
And the coefficient essentially just changes the scale.
Right.
So it's like, you know, if I got my computer and I made it twice as big, it's still doing the same stuff, twice as big, like that, all the same dimensions.
It's like the whole transformation thing that we did.
It moves it. I just put it into Desmos and it's kind of interesting to see. I don't know if you can see it. But you can like add zeros and you can shifts it like that.
Yeah, just
That's a
the
good video.
scale of it.
That is helpful.
And is there something else you're confused about?
I'd like to go back to Anda's question on the coefficient changes things, but, and part of it is that vocabulary term, right? In terms of the coefficient, the exponent, right? So, can we break these down now that, and I tried to put this in the Monday, Tuesday, the original data set. I tried to put these into the original data set. Let's try and be very concrete here. Can someone go through what they notice about the exponent first? Because we've done the exponent now, right? What values did we get? Let's go through the process, right? The regular process that we go through. What values did we get? What do we expect it's closest to? And what's the percent error? Someone feel like they can go through that?
So for the short string, for our short string for our experimental, well, our experimental was for the wavelength versus frequency was negative 0.992 for the exponent, which is very close to negative 1. So are we going to say that our theoretical is negative 1?
That's
We
not,
agree with
it's an
that.
inverse relationship, so,
Yeah.
and it's closest to negative.
And the long string is similar, so.
And the long string is like 0.98.
Yeah, that was a
Yeah.
0.6% error on the long string.
So it's very low. For the long string, I had 4% error.
I had,
Or
I
I
had
got
a 0.6% error.
your
Maybe
long
we
string
could
had
calculate percent, like,
right. So what are
find
we?
what the percent error was.
For the short string, I got a 0.8% error. I don't
Yeah,
know.
I got that.
We all got
I
really
think I
low
had
0% error, that's right?
I had a different, I think it was just because I used it. I had a different exponent from the long string. The long
What did
string,
you have?
I had 0.994.
For the
I
long,
How many data points?
Zero
Sorry,
point
negative,
98.
negative.
Negative 0.98 for the long
Yeah,
string.
it's
are you in the,
0.98.
what's the,
How many data points did you?
Oh, did
use?
you
Other than
use
12?
I
the
guess
12th harmonic
Oh,
Oh,
that's
I
value?
actually-
did.
It's 2 rows below.
Oh, wait.
Yeah, there's like 2 rows of nothing and then there's 2
Yeah, 9 and
rows.
10 don't have
Should we
any.
just-
So did you go all the way down to 12 or did you just go 1 to?
I went all the way up to 57.6 for the frequency.
Okay.
Yeah, I have that too, but
Yeah,
should
That's all.
Yeah, I did that.
we not use those so that,
No, well,
Not
it
exactly.
actually,
It's accurate.
it makes the
Oh,
curve
right.
much more visible.
oh yeah.
It's the same as I used, I don't have the numbers on the side,
Okay.
but I separated the things because from 57.6.
Yeah, that's
Right.
the data.
I mean, the difference is very small. It might just be, like, I might have changed my decimal points in my, like, how many points I went in the actual data table. So I had, I went to the 100th for the wavelength, and then to the 10th for the frequency. For decimals.
I'm thinking
Yeah, that'll look like-
that maybe it would be easier if we just picked either the short one or the long one to focus on.
Yeah,
And then we
that-
answer the questions like
Yeah.
the experimental versus the expected and then percent
Yeah.
error, rather than like.
I personally prefer the long one, because that's the one that I put on the document already, but also, I'll do either one.
Also, we should make sure that we're all using the same exponent, so
Yeah.
should we maybe use the one that Mr. Rawson just
Yeah.
made
Yeah.
from on the class document that we all have? Will we go back to that one for a second?
Short string is like a 0.8%. Those numbers.